Ever wondered how an electric car works? What makes it move without any petrol or diesel? Well, the answer lies in its unique design and innovative technology. With the rise in environmental awareness, electric cars have gained popularity for their eco-friendly nature and whisper-quiet operation. Unlike traditional vehicles that run on fossil fuels, electric cars are powered by rechargeable batteries. This means they produce no harmful emissions, contributing to cleaner air and a healthier planet. But that's not all. They also have an electric motor. This motor is the heart of the car, replacing the conventional internal combustion engine. It's this motor, powered by the car's batteries, that propels the vehicle forward. With no need for petrol or diesel, these cars are not only green but also cost-effective in the long run. So, intrigued by these modern marvels of transportation, let's dive in and explore the fascinating world of electric cars. At the heart of any electric car is the electric motor. This critical component is what sets electric vehicles apart from their petrol-powered counterparts, propelling them silently and efficiently down the road. But how does it actually work? The electric motor uses a principle of electromagnetism to function. When an electric current is passed through a wire, it creates a magnetic field. This magnetic field then interacts with other magnetic fields within the motor to produce force. This force is what turns the rotor, or the moving part of the motor, creating the mechanical energy that drives the wheels of the car. Inside every electric motor, there are two main parts, the stator and the rotor. The stator is the stationary part of the motor and is usually made up of either permanent magnets or electromagnets. This is where the magnetic fields are generated. The rotor, on the other hand, is the part that spins. It's this spinning motion that ultimately moves the car. Now let's clear up some confusion. You might be wondering, isn't an engine and a motor the same thing? Well, not quite. While the terms are often used interchangeably, there's a subtle difference. An engine, in its traditional sense, refers to a machine that converts thermal energy into mechanical energy, like an internal combustion engine in a petrol car. A motor, however, is a device that converts any form of energy into mechanical energy. So, in an electric car, the motor converts energy stored in the battery into mechanical energy. This is a far more efficient process than the thermal energy conversion in a traditional engine. It's one of the reasons why electric cars are seen as the future of transportation. In essence, the electric motor is a marvel of engineering. It takes the electric current from the battery, creates a magnetic field, interacts with other magnetic fields, and spins a rotor, all to get your car moving down the road. Now that we know what drives an electric car, let's look at the other components that make it work. An electric car is more than just its motor. It has several other components that work together. Let's delve into understanding these key components and their functions. First up, we have the power inverter. This device plays a crucial role in converting the direct current, DC electricity, stored in the battery into alternating current, AC, which the electric motor runs on. But that's not all. The inverter also does the reverse, changing AC into DC during regenerative braking to recharge the battery. Now, the electric traction motor is the heart of an electric car. It takes the AC from the inverter and uses it to create a magnetic field. This magnetic field then spins the rotor, propelling the car forward. Next up is the power electronics controller. This is the car's brain, so to speak. When you press the accelerator, it sends a signal to this controller, which then adjusts the vehicle's speed by changing the frequency of the AC power from the inverter. Then we have the battery. This is the car's energy storage system. It stores electrical energy in the form of DC electricity, which is then converted to AC by the power inverter for the motor to use. The charge port and the charger are pretty self-explanatory. The charge port is where you plug in the charger to recharge the car's battery. The charger, which can be on-board or off-board, converts the AC power from the grid into DC power for the battery. The DC to DC converter is a lesser-known but vital component. It converts the high-voltage DC from the battery to low-voltage DC to power the vehicle's auxiliary systems, like the lights and audio system. Finally, we have the transmission. This component doesn't differ much from that of a conventional car. It transmits the power from the electric motor to the wheels. With these components, an electric car can run smoothly and efficiently. But what about the different types of electric cars? Not all electric cars are created equal. There are different types, each with its own features. Let's start with hybrid vehicles. These are the bridge between traditional internal combustion engine cars and fully electric vehicles. Standard hybrid vehicles have both an internal combustion engine and an electric motor. The electric motor assists the engine, reducing fuel consumption and emissions. The battery is charged by the engine and through regenerative braking, meaning you don't need to plug it in. Next, we have plug-in hybrid electric vehicles, often abbreviated to PHEVs. These are a step closer to fully electric vehicles. They have an internal combustion engine, an electric motor, and a rechargeable battery pack. The larger battery allows these cars to travel on electric power alone for a certain distance and can be charged electrically. Once the battery is depleted, the internal combustion engine kicks in, so there's no range anxiety. Then we have fuel cell vehicles. These are a type of electric vehicle that generate electricity using a fuel cell powered by hydrogen. They're as quick to refuel as a conventional car, and their only emission is water. However, they require a network of hydrogen refueling stations, which are currently quite limited. Lastly, we have battery electric vehicles, or BEVs for short. These are fully electric vehicles with no internal combustion engine. They're powered solely by a large battery pack, which is charged at home or at a public charging station. They produce zero tailpipe emissions, offer instant torque, and have fewer moving parts, meaning less maintenance. The challenge for BEVs is the need for frequent charging and the current limitations in range and charging infrastructure. So, as you can see, there's an electric vehicle to suit a range of needs, from those wanting to dip their toes into the world of electric driving, right through to those ready to embrace a fully electric future. Regardless of the type, electric cars offer numerous benefits, making them a great choice for many. Like any other vehicle, electric cars have their pros and cons. Let's begin with the advantages. Electric cars are renowned for their environmental friendliness. Unlike traditional vehicles that run on gasoline or diesel, electric cars are powered by rechargeable batteries, meaning they produce zero tailpipe emissions. This makes them a fantastic option for those of us keen on doing our part to reduce air pollution and combat climate change. Another significant advantage of electric cars is their quiet operation. The electric motor runs silently, providing a smooth and peaceful driving experience. This is a stark contrast to the loud rumble of a combustion engine, making electric cars a favorite among those who prefer a serene ride. Additionally, electric cars offer superior torque. The electric motor provides instant power, resulting in quick acceleration and a responsive driving experience. Plus, the recharging process is simple and convenient. You can plug in your car at home and wake up to a fully charged vehicle. But, like anything else in life, electric cars come with their own set of challenges. One of the most prominent ones is finding charging stations. While it's easy to recharge at home, it might be a bit of a challenge when you're on the road. The infrastructure for electric vehicle charging is still developing, and there might not always be a charging station when you need one, especially in more rural areas. Another potential drawback is the initial cost. Electric cars can be more expensive upfront than their gasoline counterparts. However, it's worth noting that the total cost of ownership can be lower for electric cars thanks to fewer maintenance requirements and the lower cost of electricity compared to gasoline. Despite these challenges, the future of electric cars looks bright as technology continues to evolve. As more people switch to electric, we can expect to see improvements in charging infrastructure and reductions in upfront costs, making these eco-friendly vehicles an increasingly viable option for drivers everywhere. So, we've seen how an electric car works and the different components that make it move, from the rechargeable batteries that power it to the electric motor that uses a magnetic field to turn the rotor. We've delved into the key components such as the power inverter, electric traction motor, and the power electronics controller. We've also seen the variety of electric vehicles on the road today, including fuel cell vehicles and battery electric vehicles. These cars are not just marvels of modern engineering, but they're also a testament to our commitment to a greener future. They're silent, efficient, and most importantly, they're environmentally friendly. Of course, they do have their challenges, such as finding charging stations, but the benefits far outweigh these minor inconveniences. Next time you see an electric car on the road, you'll know exactly how it works. Until then, keep exploring and continue learning. If you like the content, please subscribe to our channel. Thank you for watching, and please take care of yourself as well as the environment.